Okay, everyone, we'll look at the answer for this. So first question, so show that we have this equation that has a root in between x equals to 0 and x equals to 1. So for this one, okay, whenever we want to show an equation, there is a root in between two values of the x. So for this case, we actually look at the sign change rule. So the first thing is once we are given any equation from there, okay, we need to rearrange this equation until we get a 0, okay, at one side. And what we do is we let the equation to be fx. Okay, so this is what we do. Okay, we let the equation to be fx. And next what we do is we will actually substitute the two values. Okay, so we have the 0 and 1. So substitute the values into our fx and show that we have got two values. Okay, so the two values should be in opposite sign. Okay, so with this, okay, it is not enough. I just stop there. Okay, we need to give some statement saying that, okay, because of the change in sign, okay, when we have x equals to 0 and x equals to 1 for the fx. So in that case, our fx equals to 0, okay, which is the equation that we are supposed to solve, has a root in between x equals to 0 and x equals to 1. All right, so that would be for the first part. For the second part, okay, we are already given the iterative formula with the initial value, which is also given as well. So to find this root, correct to 4 decimal places, okay, showing the result of each iteration. So basically, since the iterative formula is already given, we just apply from there. Okay, with the first value, the initial value is x naught is equals to 0.5. So okay, of course what we have is we have the first value here, which is x naught is equals to 0.5. And when we actually want to calculate the next value, okay, which is in this case the x1. So remember, for the first value, usually we have to show, okay, how do we get the first value? So we only have to do this only for the first calculation that we do. So we just substitute the 0.5, okay, into the iterative formula, and this is the first value that we get, okay, from the calculation. So when we actually give the value, just take note that when we have to look at the question. So in this case, the question never gives for each iteration, okay, what is the decimal places that we need to give. So because, okay, they want the answer in 4 decimal places, so it is good for us to always give more decimal places in the iteration. So in this case, I actually did like 6 decimal places. So it's easier for us to detect what is the answer for this, okay, to 4 decimal places. So of course we get the first value from there and just continue, okay, to actually substitute these x values into the iterative formula, and we actually have to calculate from there. So when we actually calculate, okay, from there, and for this one, we get to the result quite fast. In fact, by looking at the last 3 values here, or in fact the 4 values here, the 3 values here, we actually see that the value for this x is 0.3399. Okay, rounded to 4 decimal places. So that would be for the first question. Okay, for second question, okay, what we have is we have this equation sin x minus x plus 1 is equals to 0. Okay, has a root in between 1.5 and 2. So for this one, again, is by using the sign change rule. So we make sure that for this equation it is equals to 0, and we let the fx to be the equation, and we just have to substitute the 1.5 and 2 into the fx and show that they have opposite sign, okay, for the values. So from there, give a statement saying that there's a sign change, okay, in between the two values. So therefore we actually have a root, okay, for this equation in between the two values of x. Okay, so for part 2, okay, by using the iteration, okay, given with the suitable starting value to find that roots correct to 2 decimal places. So for this one, they gave us the iterative formula, but they never give us a starting value. So in this case, the starting value, we can use any value, okay, that we like, okay, from 1.5 to 2. Just use any value from that. You can either use 1.5, use 2, or any value just in between that. So in my case, I will actually use a 1.75. Okay, so for the first value, okay, always remember we need to show how do we get the first value by substituting the initial value into the iterative formula. So we get this, and for this we know that the answer that we're going to give is we need to give it in 2 decimal places. So for this, okay, the iterative formula we give to 4 decimal places. Okay, so just continuing the working from there, and from the last few calculations here, we can actually see that the value when we actually round off to 2 decimal places will be 1.93. Okay, so that will be for our part 2. Okay, part 3, sketch a graph of a sine x and y is equals to x minus 1 on the same set of the axis. So for this one, okay, although the graph is very easy to sketch, okay, so there's something that we have to be careful lah. So let's say we first sketch the graph for y is equals to sine x. So remember that when we have x is equals to pi over 2, the value of the y here is a 1. Okay, so this value here, it is a 1. Okay, and at the same time we have got the y is equals to x minus 1. So in this case we know that the y-intercept for this straight line is y is equals to negative 1, and for x is 1. Okay, so make sure that the value of the 1 is correctly labeled. Okay, it is before the pi over 2, and make sure the straight line is correct as well. Okay, so this straight line, okay, must go through this sine x curve before this highest point. So it must go through this one before, okay, the highest point here. In fact, if we actually follow the scale nicer, we will actually get a more accurate graph. So in this case, I didn't really follow the scale, but the main thing that I want to highlight is that this line, okay, cannot pass here like this. Okay, it must always go before this highest point for the sine x. Okay, because of the value 1 from there. Okay, so that would be for the number 3. Okay, so from there, okay, what we have is we actually have the part 4. Okay, explain why this equation has no root other than the one that is found in the part 2. So in part 2, we already found one solution. So what is the solution here is, of course, the intersection in between the two curves. So in this case, we see that we only have one intersection point. So that is why we only have one solution from the part 2. Okay, so this is basically what happened for the second question. Okay, the third question, okay, involves a little bit of the circular measure. So it is given that, okay, we have got this shape, and then it is given that the area of the AOC is the same as the area of the segment. So basically they are referring to this one. So this area is the same as this area. And it is not really difficult for us to find out, okay, what would be the area for these two. So if you look at the triangle, so for the triangle, we already have the hypotenuse, okay, the length is a r, and also we have the angle is a theta. Okay, so for the length for AC and OC, they are just r sine theta and r cos theta. Okay, so this help us to find the equation of the triangle. So equation of the triangle is half times the base, which is the OC, and times the height, which is the AC. Okay, so from there we will have the triangle, we'll have this area. Okay, so what about for this segment? So for this segment, it is quite straightforward because we have got the angle already. The angle is theta again, and the radius is r. So the area of this segment, okay, is given by half r squared in the bracket theta minus sine theta. Okay, and then before this we already say they are equal, the area, so just equate both of them, and we can actually cancel out the half r squared from there. So basically from there it's about rearranging the equation. So after we rearrange, we should be able to get what we need to prove, okay, from the question. So that will be for the part 1. Okay, Part 2. So using iterative process, okay, of this equation whatsoever, okay, find the value of this root correct to three significant figures by using starting value of the 1. Okay, so so after that, use a change of sign to verify the value that we have found is correct, okay, to three significant figures. So okay, there are a few things that we need to take note here is that they never give us the iterative formula. Somehow the iterative formula is obtained from the first part here. So if they never give us the iterative formula, it is good for us to state what is the iterative formula, okay, rather than we just start calculating. So, okay, what we need to do is state, okay, what is our iterative formula, because we're going to use this to do our calculation later on. Okay, although it is quite obvious from part 1 already, but part 1 is just an equation. It is not the iterative formula. So give your iterative formula for this one. And it is given that for the first value, okay, for the theta, so our theta naught is a 1. And for the next value, always remember, we have to substitute this, okay, and show our working, okay, say how do we actually calculate the next value. And remember, whenever we are not working with the trigo, so we are working with this kind of solving the equations, and we have got like something like differentiation and integration. So always use the radian. Okay, so always use the radian when we actually do this calculation, else we will actually end up with something else already. So by using the radian, okay, we substitute the values, okay, we find out the values, okay, in the answer, what we need is we need 3SF. Okay, so in our step in the middle, okay, we should actually give more than 3SF. So in this case, I give 4 decimal places to be safe. So for this one, okay, we can actually see that towards the last few values, okay, the values when we actually round off to 3SF, they are actually similar. So in that case, we actually have the theta rounded to 3SF is 1.25. Okay, so that would be the value for the theta. And not to forget, we still have to do the last part of the question. So for the last part of the question is we need to use the sign change, okay, to show that this value, which is 1.25 that we have obtained, is correct. Okay, so how do we do is first, because we want to use the sign change rule, so the sign change rule must always, okay, start with an equation that is equals to 0. So this is the equation that we have proven in the first part. So we cannot use this straight away. We must rearrange it until we get as equals to 0 for one side. Okay, then next we will actually let this equation to be fx, but for this case it's a theta, so I made a mistake here. It should be f theta. So from the f theta, what we do is we substitute two values, because we have found this root is 1.25. So this root, okay, is correct, okay, only if this root is in between two values for the theta. So in this case, we try to use 1.2 and 1.3 and show that for these two values of the theta, the f theta gives us a different sign. So in this case, they give us different sign. Okay, so what does that mean? So it means there is a root which is in between theta equals to 1 over 2 and theta equals to 1 over 3. And from the value that we have found is 1.25. So this 1.25 is in between 1.2 and 1.3. Okay, so in that case, we say that this root, which is theta, equals to 1.25, okay, is a root of this equation, okay, because of the sign change rule. Okay, so that will be the solution for the third question. Okay, so I made all the mistakes here. It should be all theta, not x. Alright, so the last question that we'll look at is we have got this equation has a single root alpha, okay, which can be found using an iterative process. And first part, okay, use the sign change method to find the pair of consecutive integers between which alpha lies. So we know that for this one, the alpha is a root, and we need to use the sign change method to find out, okay, what are the values that this alpha lies in between. Okay, so we know that if we know that alpha is a root, so it must be in between two values of the x in this case. That gives us sign change. Okay, so first, in order for us to use the sign change, okay, always make sure that we have got the equation which is equal to 0. And next what we do is we let it to be fx. Okay, so the process which is followed by this is more like trial and error. So we try, okay, when we have x is equals to 1, we get a negative value. And luckily, when we actually use x is equals to 2, we get a positive value. Okay, so from there we already proved that the alpha is in between 1 and 2. So the 1 and 2 is, they are integers and they are consecutive integers. So this alpha will lie in between 1 and 2. Okay, so that would be our first part. So we will look at the B. So B is, we use this iterative formula to find the value of the alpha. Okay, so determine the values for the constants P and Q, and hence find this alpha correct for 4 significant figures. So in that case, okay, what we need to do is we have to rearrange this equation. Okay, if not, we cannot get the iterative formula. Okay, so when we actually rearrange this equation, okay, so this is how we rearrange the equation. So move the negative x and negative 2 over, and divide the whole equation by an x first, then only we square root. Okay, so from there we can actually find out what are our P and Q. So we have got the iterative formula already. Okay, and from there we have got the first value, the initial value. We can use anything because we already proven that the alpha is in between 1 and 2. We can just use any value in between, or you can just use 1 or 2 to start with. Okay, it doesn't matter. So for the first step, remember, is we have to show how did we get the first value. And from there, okay, just proceed with the calculation. And because we want the answer to be 4SF, so just observe the trend. So the last tree, when it actually gives us, when we actually round up to 4SF, it actually gives us the same value. So in this case, we have already found that the alpha in this case is 1.521. All right. So that's all for this exercise. Okay. So that's it. Thanks everyone. So I will see you tomorrow. Thank you.